In this example here, we know that the third term of a geometric series is 16. It is increased by a factor of 0.5, and the sum of the first 10 terms of this series, we want to find the sum of the first 10 terms of the series. So what this question is asking is, what is the value of S10? So we know that the formula is what? Let me remind myself here. So we got the first term. We have a times r to the n minus 1 all over r minus 1. So I need to figure out what my first value is, and my r value, well, that's 0.5 because it says increased by a factor of 0.5. So I can write this as a times 0.5 to the exponent n minus 1. Actually, the n we know, that's going to be 10. So 0.5 to the exponent 10 minus 1 over 0.5 minus 1. Let's see if we can figure out what the first term is. So we're given the other piece of information. The third term is 16. So right here, and the way I write that mathematically is that T3 is equal to 16. But the expression for T3 is a times common ratio n minus 1 equals 16. And since it's the third term, and we know the common ratio, we know it's 0.5, 3 minus 1. So let me just simplify this expression. 0.5 to the exponent 2 equals 1/6. And I want to solve for a, which is going to give me my first term. So I have a times 0.5 is 1/2 squared equals 16. A times 1/4 equals 16. And final step, I'm going to multiply both sides by 4, and I get a equals 64. So 64 is my first term, and if I go back to my formula, I'm going to replace my a values with 64. 64 here, 64 here, and let's see what we get. So we have 64 times, so on my calculator, I'm going to go 0.5 to the exponent 10, and I'm going to subtract 1, and I get a very long decimal number, negative 0.999 again, 0.234375. Close bracket, all over negative 0.5. So doing the math here, let's see what we get. Times 64, I get 127.875. And there's a sum of our first 10 terms in the geometric series.